Right, we're continuing with question 6. In this video, we are also differentiating. This time, we are differentiating using the rule, okay? So in the previous video, and I'll encourage you to go watch that video again. In the previous video, what we did was we differentiated. We found the derivative, right? Differentiate derivative. We found the derivative from first principles. You will always have a question like that. You will always need to be able to do it from first principles. But then you will also have a question that you need to differentiate using the rule. Okay, and then maybe also within your cubic function question, you'll have to do that there as well for your turning points. But I guess we'll get to a question like that. So let's do question 6.2 quickly. And in order to differentiate here, we need to use the rule. So let me first cover what the rule is, and then we'll get into our question. So I'm going to make a statement first. The rule is exponent times coefficient minus 1 from exponent. Now let me tell you what that means. So I'm first going to write some algebra. Let's say you have f of x, right, and you have a x to the power of n as your expression, right? So if I'm finding the derivative, my symbol is now f prime of x. So we should know that there's a lot of options, different options for the symbol. So f prime of x, or I can even say m because we know derivative is gradient, or I can say dx, or I can even say dy dx, or I can say dx. So all of these symbols mean the same thing. They mean derivative. Okay, and the more that you see them, the more comfortable you'll get. So let's not worry too much about that for now. Okay, the symbol that I'm going to use for this one is going to be f prime. So derivative of f. So again, what I said was exponent, right? So here's my exponent, and the exponent needs to multiply with the coefficient. Right? And that's going to become the new coefficient. So if I'm talking in terms of my variables, it will be the n times the a. That's the new coefficient. And then the x, the variable stays the same, but we're going to take 1 away from the exponent. So the exponent now will be n minus 1. Okay, what does this mean? Let's look at one that actually has numbers. So if I have f of x, and maybe this is 2x to the power of 3. Okay, again, what did I say? I said exponent times coefficient, right? So if I'm going to say f prime of x, the 2 is going to multiply with the 3, and that's going to give us 6x, and I'm going to subtract 1 from the exponent. So it was 3. 3 minus 1 is 2. Okay, so what did we do? We said exponent times coefficient minus 1 from exponent, and that's how we take the derivative using the rule. Okay, so that's what we're going to do in basically this whole question. If I look at 6.2, okay, let's rewrite that fast quickly. 8 x to the power of 8 minus, so let me say, is it y? This is y. So y is equal to x to the power of 8 minus 2x cubed, 2x cubed, all of this divided by x to the power of 6. Okay, so when it's in this form, I can't factorize, or not factorize, I can't take the derivative when it's in this form. So I need to break it up so that I can have separate terms. Okay, so what I'm going to do is this one over here, that is going to become a fraction. And this one over here, that's going to become a fraction. Okay, so what am I going to have? Still y, because I haven't taken the derivative yet. I haven't applied the rule yet. I'm going to have the 8, or rather x to the power of 8 divided by x to the power of 6. Okay, so what did I say? I said that one becomes a fraction. So that's the fraction I have there. The minus sign, which is from there. And then this one is going to become a fraction, which is 2x to the power of 3 divided by x to the power of 6. Right, so now I have separate fractions, which is great, separate terms. I need to just simplify this first before I can actually get into applying the rule. Okay, so I know my second exponential law tells me if my bases are the same, I'm going to and I'm dividing, I'm going to subtract exponents. So this first term is going to become x to the power of 8 minus 6 is going to give me a 2 as an exponent, minus 2x to the power of, so 3 minus 6, and that's going to give me a so it's going to be 3 minus 6, and that's going to give me a minus 3. Okay, so this is this is still y. This is now in a form where it's ready for me to apply the rule. Okay, so let's just mention this. If you have any fractions where your variable's at the bottom, you want your variable to be on top. Okay, so let's maybe just make an example quickly. I'll come back to that question. Let's say I have something like maybe 2x to the power of 3 at the bottom. We should know from our exponential laws that it's possible for me to move this thing from the bottom to the top. But if it moves from the bottom to the top, what we should know is the sign on the exponent changes. So this would be the 2 stays where it is. This is now on top and it's become x to the power of -3. So again, if there's a variable at the bottom and you're moving it to the top, the sign on the exponent changes. And I just become comfortable with that because you will definitely see that. Right. Okay, cool. This is now in a form where it's ready for us to use this. So I see that I'm working in terms of y. So if I'm going to take the derivative, then I'm going to say dy dx. I'm using this symbol now because I'm talking in terms of y. What does this symbol mean? I'm taking the derivative of y with respect to x. What does it mean if I say with respect to x? I apply my rule on the x's. If there's any other letters in the question, you don't apply the rule on those other letters. You only apply the rule on the x. For example, if there's a t there, you will treat the t as a constant, as just a number, okay? Because you're applying the rule on the x. So maybe like, let's say plus t squared. Then this, you treat it as if it's a constant. Okay, I'll discuss what you do with a constant maybe after this one. All right, so this is the symbol I'm using because I'm speaking in terms of y. Okay, so now I'm going to apply the rule. What was the rule again? Exponent times coefficient. Now I know there's invisible 1 in front there, invisible 1. So 2 times 1 is a 2x. And I know I'm supposed to subtract 1 from my exponent. So there was a 2 as an exponent. 2 minus 1 is 1. So I know that invisible 1, I don't have to write it. Then I'm going to apply the rule again for my second term here. So what is the rule? Exponent times coefficient. Now what's my coefficient? The -2. So -3 times -2, minus times a minus is a positive. 3 times 2 is 6. And then x. Now my exponent is currently -3. And if I'm going to take 1 away from -3 minus another one is -4. Okay, so there we've applied our rule. We are done. Okay, however, I'm not sure in technical math, but in pure math, you don't want your negative exponents. So what I mentioned earlier about moving it, right? So if you want positive exponents, you'll take this one and you move it to the bottom, and moving it to the bottom would give it positive exponents. But I think in technical math, we're happy with the negative exponents, so we're done with this one. Okay. Yeah, what I mentioned was I wanted to speak about the constant. So let's say you have, let's say y is equal to 7. So 7 is just a number, a constant. And now I want to say dy dx. So now I need to apply the rule on the constant. So short version, the derivative of a constant is 0. That's the short version. So this answer is going to be 0. But now I want to explain to you why it is 0. Okay, short version, derivative of a constant is 0. Okay, so the our explanation, next to the 7, which is a constant, there is an x. It's invisible, but the x that's there has an exponent of 0. So what we already know is that anything to the power of 0 is equal to 1. So what this actually means is just 7 times 1, and 7 times 1 is still 7. So what I'm saying is this thing exists, it's there, we don't see it because it's actually a 1, and if 7 multiplies with 1, it stays the same. But when we consider applying the rule to take the derivative, we know it's exponent times coefficient. So it's 0 times 7, and 0 times 7 would just be 0. Okay, short version, derivative of a constant is just going to be 0. Okay, now this video is already 10 minutes. I'll cut it here, and then I'll do the next question. Let's check what was the next question. So we simplified. That meant we broke it up. We got it into the 2 parts that was ready to differentiate, so 2 separate terms. And then this part over here, we applied the rule. In the next video, we'll do this one. But again, it's going to be the same thing. So the first thing we need to do is to get it ready to apply the rule. And then in the second part of the question, we apply the rule. Okay, let's get to the next video.